Good morning. So today we are going to go on a journey together. We are going to leave behind what we think we know and search for harder earned knowledge that is ultimately rooted in the way that we as humans work together. So first we have to...
We have forsaken the land and gone to sea. We have destroyed the bridge behind us. More so, we've demolished the land behind us. Now, little ship, look out. Beside you is the ocean. It is true, it does not always roar, and at times it lies there like silk and gold and dreams of goodness. But there will be hours when you realize that it is infinite, and that there is nothing more awesome than infinity. Oh, the poor bird that has felt free, and now strikes against the walls of this cage. Woe, when homesickness for the land overcomes you, as if there'd been more freedom there, and there is no more land.
So we're going to leave the land we know, get on that little boat together, little birds, all of us, you and I. Does anybody know who that was? Not you. No? We had someone know at the last one. I'll let you think on it. I'll reveal it at the end. So along this journey, we're going to stop in the shallows, and we'll talk about some of the usual suspects. Shallow data is a term that John Alspaugh coined to capture the fact that these types of data tend to obfuscate the messy details that are really informative about the incidents that we have in our systems. And worse than that even, they can convey a type of certainty that distracts from the work that could reveal more useful information about how your systems work. So what I'm about to do is condense an entire talk on these data into maybe 10 minutes at the most. If you want to find me afterwards, I'm happy to talk more about these things. I also have a couple of the reports that's shown right here. I think I only have 2 of them with me printed out that I'm happy to give to anyone who has questions about that. But we're going to spend this next little bit in the shallows before we venture off into the depths, talking about a few of these: duration, mean time to recover, severity, and root cause. So let's talk about duration first. Well, my little animated GIF that was supposed to load doesn't load. There's always got to be something. What you should be seeing on the screen right here is a GIF that is showing a series of histograms of duration data that I've collected from a variety of companies. And these are all in what's called the Void. It's a database that I have of over 10,000 incident reports, public incident reports. And for those that we are able to collect duration data from, we've managed to chart those data and look at the histograms of what those data look like. And what you would be seeing here is a chart that shows the count of the number of incidents for each company by time. So under an hour, under 2 hours, under 3 hours, sort of this duration of the incident. And what it looks like is a very skewed data set. So many of you are probably used to seeing a nice normal curve like this, and none of your data look like that. They all look like the GIF that's showing in my speaker notes that's not showing on your slide. So that's really unfortunate. But if you can imagine a very left-skewed set of data repeating over and over again, all your duration data look like this. None of your duration data have a nice normal distribution. And what that means statistically is that taking an average, the mean of those data, is ultimately meaningless. It can't tell you what you want it to tell you, what you desperately believe and hope that it will tell you. And in fact, here are some of the things that we often think that mean time to recover will tell us: how reliable your software or systems are, how agile or effective your team or organization is, if you're getting better or worse at responding to incidents, whether the next one might be shorter or longer, how bad any given incident actually is These are all beliefs and myths that we tell ourselves based on the duration of our incidents. And I am suggesting that you move on from this metric, not just because it's deceptive, but it's inaccurate, it's unreliable, it won't help you. And you need to move beyond this to start to discover some of the real depths and truths of your systems, and it's possible. People do it.
When is it over? What are we going to decide is an incident is over? Are we recovered? Because oftentimes you're mitigated, but you still have a degraded system that is either costing a lot to run or may be at a high risk to fall over again. The aggregate wasn't really telling us anything. Looking at mean time to recovery and trying to learn anything just from that is like looking at the presents under the Christmas tree and trying to guess what's in them.
Oh, I love that metaphor. Okay, in our speed run through the usual shallow suspects, we come next to severity. And the notion of severity as being negotiable is yet another concept that I'm borrowing from John Allspaw. It's a variable proxy. So it's a proxy that can be used flexibly, differently, even within the same team or organization for different things and different meanings, things like customer impact, or perhaps the effort required to fix, or the urgency of the issue. Beyond that, sometimes it's automated, sometimes it's not. Sometimes it's updated, sometimes it's not. It's ultimately subjectively assigned. In many cases, severity is gamed, right? To draw attention to getting assistance for an incident, for example, or triggering or avoiding triggering a post-incident review, to get management approval to invest in something, or to invoke or avoid invoking SLAs or SLOs or those types of things. So it's ultimately very subjective. And John, again, refers to this essentially as a coping strategy given the uncertainty of the environment in which we deal with these.
The first thing that comes to mind about severity levels is that different organizations use them for different purposes. They're like ratings. They have value, but they don't have any value in the way that some organizations would love for them to. You can't boil down. They're not like pressure or temperature or height or weight or length, or any sort of credible, demonstrable, solid measurement of a thing. So the value is not in the value itself. What we are interested in is how do they change? Who gets to change them? How often are they changed? How are they used? And are they used in different ways for different reasons with different audiences? It's a coping mechanism. It's a coping strategy that is really lossy. It would be like having red or yellow or green symbol to represent the front page of the New York Times. That's how oversimplified it is.
I don't have a good visual for that. So that's John talking in the abstract to some degree of how this works. And this is somebody talking about their lived experiences with how severity has functioned at organizations they've worked at.
At a previous job I had, severity served at least two purposes. First, signaling how many people should be jumping in to help, and second, deciding whether or not the impact counted against the team's availability metrics. So the practice of severity differed a little bit depending on who picked up the incident commander role. There was a general pattern where severity would rise and fall according to how much help was needed. For example, one started out as a Sev 1 because the impact was widespread. A remediation was found, but there was still a huge backlog of messages that needed to be consumed on the Kafka topic. The status would drop to a Sev 3 while a few people monitored the burn down of that backlog, and most people got onto their other work. Then they'd close the incident when the topic was back to...
Every time. I play it in the regular thing, it doesn't cut it off. Every time I do it in the presentation, it cuts it off. Sorry. So what was that? Was it a 1? How many people think that was a Sev 1? How many people think that was a Sev 3? How many people think that was a Sev 1.5? So I want to bring back to just some of the data that we've collected, because oftentimes when I talk about duration and I try to convince people that MTTR is fooling them, they say, well, there's got to be something about duration, right? It feels like it is meaningful, or maybe it tells us something other about our incidents. Maybe the longer ones are worse or aren't worse or something like that. So we went and looked at those data that we had in the void, and they're not correlated. So within an organization, within their own set of incidents, you can have long ones that are really bad, short ones that are really bad, everything in between. And so this chart is essentially showing over a period of time the number of events for a given organization, and the height is the duration of that incident. And I apologize, not the most accessible and probably hard to see in this size, but the color is a sort of red, blue, green, yellow, orange, horrible kind of thing. So you've got long yellow and reddish medium ones, you've got long blue and green ones, and so just visually, they're not related, but statistically, they're not correlated. We could not find within a single organization any actual statistical relationship between the length and the assigned severity of an incident. So they're not helping you. They're not telling you anything that's going to help you understand how your systems work or what to do. So the other one that I just want to talk about, that we talk about in the void quite a bit, is the notion of finding or designating a root cause, or doing a root cause analysis. And the reason I want to bring this up is that it's still a fairly common methodology in our industry when it comes to incidents, to the point that people are now verbing it. Root caused it, which makes the formatter and me have like hives, but that's not really the point of this presentation. The problem is that it tends to simplify, and all of these are often, not always, but often simplifies the causality in your complex systems. And many of the things that if you came to Lauren's talk, it's like, how would you find a root cause in that world? The adaptive universe does not have a root cause, other than that David Woods called it that. It fails to identify upstream or other systemic factors, and it tends to over-index on like human decisions and actions. And these are all things that can stop you short of discovering much more of the truths of the realities of your systems. And this is just an example of how
in
others
hindsight,
think.
we typically oversimplify causality, right? And think how that works. I mean, you start at the outcome and then you walk back. And then it becomes very easy to say, well, hang on, walking back, it's obvious that this led to this. But that's unfair, because you're walking back and the people who you are investigated were going forward. And that's a very different way of experiencing reality, obviously, in which causality isn't clear or as clear at all.
So I'm trying to convince us to stop thinking we have so much clarity or so much certainty. So we're going to try to leave the shallows now and go together into the depths. This is you, my intrepid scuba divers, I don't know. And this one always makes me think of this quote Walt Whitman wrote. It says, "Do I contradict myself? Well, then I contradict myself. I am large. I contain multitudes." And I want us to envision a world where instead of reporting on incidents, we discover their stories, because our incident stories contain multitudes. And so here we go to try to discover some of those stories and what they can tell us. And there's a reason we have so many tactile metaphors for stories, right? They're woven, raveled or unraveled, crafted, honed. These socio-technical tapestries give depth and texture and color to our experiences that an incident report can't quite give. And they're not linear, they're not one-dimensional, they contain patterns, they contain multitudes, and they're not fixed in time. And when we invest in finding these stories, there's so much more that we can understand about ourselves and the systems in which we operate. And here are some people's own words, not me just telling you this, but their experiences at doing this and what they found.
in terms of telling these kind of stories, it serves a purpose that is not really served by anything else that we do, even postmortems or even documentation, because this is basically memory. We have memory as people, and we share that memory across people by telling stories. We need to do that as engineers, and the only way that we can actually do it with people across different organizations by writing it down and having that collective memory grow.
I just really love telling stories. I think storytelling is one of the fundamental ways that humans interact, learn from each other, support each other. There are so many cool incident stories out there that aren't being told. My motivation as I was going through this process was to set an example and to say, hey, this is one way that incident stories can be written, can be told. I really was hoping, and I still am hoping, that the folks at other places will come across this set and say, oh, I could write a story like this.
Two things about those two stories. The first one about memory and humans really makes me think about what Lauren was talking about yesterday, about the hardest problem in software is getting the right knowledge in the right people's heads. And stories are such a powerful way of doing that. Like, we're wired to consume and remember and retell stories. And then the other thing that I love about this part that Courtney says, they were talking about this really wild series of events they had during the Wall Street Bets, GameStop stuff a few years back, and they wrote sort of an anthology of some of their incidents, which I thought was really cool and makes me think of Clint and his archaeological paperwork. But Courtney was inspired to do this by Laura Nolan, writing her Slack outages. He'd read hers and said, well, if she can do that, then I can do this. And then if I can do this, then I can inspire someone else to go and do that. And so I think the other piece of this that you may not realize is we all read these, right? All the incident nerds read them, but in doing this, in sharing this information and being transparent, you are quite literally inspiring other people to do the same. You are infecting the system in a very good and powerful way. So here's a few more perspectives.
Going through the cast of characters is really interesting because I think that's how we wound up in this situation. 2 years ago, we had one Kafka expert on the team. And then I started doing some Kafka work. And then the Kafka expert left the company. So it was just me for a little while. And then the platform engineering manager made the decision of, okay, we think we're going to try this new tiered storage thing from Confluent. Let's sign the contract. Let's figure out the migration. And we thought we had accomplished all of it. And then we had one engineer from our team sign up to finish the migration, right? Like, it's already running in dog food, make it run in prod. And then when we started having a bunch of incidents,
there was this transfer of knowledge, and sometimes pieces fall on the ground, and that's where some of the surprises come from. It's not something for which you can have quantitative metrics, right? It's something you have qualitative metrics for, which is, do you feel nervous around that? Is this something that makes you afraid? And getting a feeling for the feelings that people have towards the system is how you kind of figure that one out. Someone who feels extremely confident are not necessarily going to take extra precautions for the sake of them, but everyone was sort of walking on eggshells around that part of the system and feeling or self-imposing pressure about the uptime because people take pride in the work they do.
There's multitudes right in there of what Liz and Fred said. And so few incident reports would even tell you that Kafka got weird because someone was there and then they left and then they had that expert and then the handoff didn't work and they lost that amount of information. And typical incident reports aren't going to tell you about how you get the feelings for the feelings that people have about their systems. These are depths and details and rich information that you only get when you move past those shallow, not just metrics, but descriptions and portrayals of your incidents. You find out about the roles these people have, the way they feel about their systems, production pressures, all these kinds of things that come up in the adaptive universe where resources are finite and change is constant. There's another one.
The good thing was that we could kind of tell from the pattern of the crashes that it was something that was going into some type of kind of exponential backoff. And I think having run this system for a while now, one of the patterns that you realize is our async work that exists in Google PubSub. When you fail to ACK a PubSub message, you'll go into a standard exponential backoff pattern. So the fact that we were seeing subsequent crashes come maybe 2 minutes and then 3 minutes, 4 minutes, that sort of thing from each one of the retries, that gives you a pretty strong gut check that this is probably coming from some PubSub messages. And then you start looking for where have we got kind of an errant PubSub message across all of our subscriptions. So you start looking through them and going, cool, the subscriptions that I know I'm okay to clear, I'm going to start clearing, and we were just basically going through those and trying to clear them out so that we could get rid of the bad message, which presumably was the thing that was being retried each time and bringing it down.
So what I love about this one was I read the incident report and we talked about it. Those patterns weren't really evident in the report. When I talked to Lawrence, then we found out and talked more about what that pattern was. I asked, you mentioned something. You mentioned knowing something from before. What was that? Oh, it was this pattern. How did you find that pattern? How did you know that pattern? Oh, well, so like pulling on these threads of this tapestry was finding more of these ways that this expertise that these people have, this hard-earned expertise, plays out in how they manage their systems and how they react and how they adapt when it doesn't work the way they expect.
While we're going through them, we sort of by osmosis noticed some stuff. And that is another sort of unstated reason to do this. From a perspective of a squad that's trying to help people be better at being reliable and resilient and building their systems, we certainly got a good, broad picture of what's going well and what's not.
So if any of you came to Clint's talk yesterday, one of the other things I talk about, if you really delve into your incidents, we're talking a lot about depth here, but his talk yesterday was about breadth. And so they gained all these other insights about what was working and not working by looking across many of their sets of incidents. And in doing that, they actually found that MTTR told them nothing. But all these other things became evident to them as they started to go through, and they found patterns and they saw these broader, sort of higher level themes that they could start to chase to help them understand what was happening. We're going to go further down into the depths now and talk about things that are much harder to discover if you're stuck in the shallows, if you will. And this comes from, to some degree, the notion of the law of stretched systems. And Lauren, forgive me for continuing to refer to your incredibly awesome talk yesterday. But the notion of safety boundaries, if I say safety boundaries, does that have meaning? Like, does that mean something to you, or are you like, I honestly don't know what you're talking about here? Yeah, okay. So maybe a third, maybe not if that, of folks here, maybe more like a quarter. So this diagram I really love. It's from a fellow named Rasmussen. He developed this in 1997. It's sort of been an evolution of many concepts in safety science, not even necessarily for engineering. Okay, so this has come out of looking at other kinds of work in other safety critical types of systems, but I love how unbelievably applicable it is regardless of what your sort of industry is, as long as it is some form of complex, often high tempo, sort of typically safety, in some way safety critical type of system. And how do I get the pointer? I don't know. Troy, how do I get the pointer? Oh, there it is. The other thing I really love about this, as I was doing this, is I realized it looks like a fish. So, metaphor complete. Okay, let me break this down a little bit. And also I just want to say, the caveat I have for this is, the first time I saw this diagram, this is a sort of simplified version of Rasmussen that Dr. Richard Cook, who many of you might hear the name keep coming up and up, was a colleague of David Woods and John Allspaw, sort of a scion of the industry who unfortunately passed away last year. I saw him present this at a Velocity conference, not here, I think it was in New York. And I was like, oh, that's cool, I mean, yeah, sure. I didn't get it. Like, I didn't get it. And somebody recently, I think it was Jason from Indeed, asked me, when did you get it? And I was like, well, sometime between then and a little while ago. right? Like it just wasn't something that clicked for me. So if it doesn't click for you, that's okay. But it will become one of those things I feel like that you can't unsee once you've seen it, and then you'll see it in places, or you'll understand how it applies to your own even unique situations and systems. So the notion is that there's 3 safety boundaries for these kinds of systems that we operate. This one up here is the sort of economic failure boundary. And essentially, if the lights are on, if you're paying rent, oh, this one gets weird right now. If you're, selling things and making money, then you have not crossed the economic failure boundary. You're still in here. And then this one is considered an unacceptable workload boundary. And that's if you're not, burning people out, overworking people, laying them off. This gets weird again down in here. But if you have people who are here doing the work and keeping the lights on, and they're not out here, then you're within this boundary. This is the boundary that we tend to play with the most, barring recent events, in our industry and other industries. And it's exactly when this is the sort of acceptable performance boundary. When Lauren, if you went to his talk, was talking about the law of stretched systems, right? In our industry in particular, we're always trying to be as close to this boundary right here as we possibly can, right? We want to push our systems as hard as we can, and so that we're also, we're not failing here, but we're definitely succeeding within that. So then this is you, right? Or your team, your org, your company, your product, whatever. And the point I want to make, a couple points I want to make about this. One, this moves around. These move also. These boundaries move in ways that you may or may not be aware of. And this moves around in ways that you may or may not be aware of. And Dr. Cook would even refer to the way this moves around as sort of Brownian kind of motion, if you're any sort of a physics nerd. But the most important point that I want to make about this point is you don't know where it is. You think you do, but you don't. You don't know. Is it over here? Is it over here? Like in general, on any given moment, you don't know where it is until it's here. Somewhere out here. Oh shit. Okay. So this is such a fantastic diagram to describe the world in which we live, the sea in which we swim. And it turns out if you spelunk your incidents deeper and with greater care, you can start to discover some things about this that you may or may not have been aware of previously. So I'll give you 2 of those around trying how the operating point is dynamic and how are you trying to figure that out, and then sort of how people discover and adapt to those, right? We're the adaptive capacity in the system that can help handle where that operating point is moving.
So that was giving us kind of, this looks bad. It was also part of a piece of the code base that we had seen an error come from, I think, the day prior. So we were already feeling a bit suspect about this. We didn't quite know how it would have happened because we were under the assumption at this point that any errors that were returned by these subscription handlers, regardless of whether or not they panicked, the app should proceed and continue. So as it happened, that was an incorrect assumption. At this point, you already don't have a consistent viewpoint of exactly what's causing the incident. So you start ditching some of the rules that you think you have in mind because it's logically inconsistent with what you see that is actually happening in production.
So I love that quote because it's like they think you are here, and then they're like, well, we might be over here, but we're not sure, right? So at least that's an awareness now if you don't know where your operating point is. It's also a gut sense that you're moving towards that boundary of operating performance, right? There's another one.
It's trading one mechanism of safety for another. We traded off having the disk buffer, but in exchange, we lost the ability to go back in time to replay more than a few hours of data, whereas previously we had 20 hours of data on disk.
That's the concept of safety margin. Ideally, we had like 24 to 48 hours of buffer so that if the core time series storage has an issue where it corrupts data, then we have the ability to take a bit of time to fix the bug and replay the data and lose none of the customer information. This speaks to the expertise of people operating the system in that they understand these kinds of safety margin and measures that are put in place in some areas. When something unexpected happens, the people who have a good understanding of where all that stuff is located are able to tweak the controls and change the buttons and turn some demand down to give the capacity for some other purpose. That's one of the reasons why when we talk about social technical system, the social aspect is so important. Everything that's codified and immutable is tweaked and adjusted by the people working in the system.
So it's a bit of an unfair one because Fred knows more about this than a lot of us do, but I still love the experience that they gained and what they learned from their own systems in Honeycomb with that one, and the way they were able to describe that in those types of terms. Like you could almost see Fred imagining their system in that, oh, we pulled ourselves away from the buffer by doing this, right? We brought ourselves closer into the safety margin on that. Okay, so 2 more places to go before we're done getting to the depths of our incident stories. Want to talk a bit about near misses as a category of incident stories. One that we don't hear a lot about. I certainly don't have a lot of them in the void in the database, and not something that you tend to look at if you're focusing more on shallow types of metrics. They don't even exist in that, they don't swim in that sea, but there's a lot to be learned from these near misses. And the averted incidents, right, the near miss, they don't get as much attention, but they contain even more interesting details, often due to the fact that they don't come with the production pressures, the potential fear, or those kinds of things. And in part, largely because a near miss is a success, right? Which is fantastic, because one of the things that I talk about when we talk about, sort of learning from failure, or what was the root cause of the failure, is to flip that around and say, well, what's the root cause of success? And a near miss is the chance to actually answer that question, which is impossible. There's no single root cause of failure. There's no single root cause of success. And the 2 sides of those are all how your system operates together. And Lauren said yesterday, no one person can see the whole system, right? We have local rationality, but the more you delve into near misses, you can start to find some of these like gaps in knowledge and communication breakdowns and pockets of expertise and mental models that don't quite line up with things, assumptions, all of these cognitive types of processes, very similar in some ways to what Laura was talking about in her talk as well. And you get to do this in an environment that doesn't make everybody feel like really worried about what's going to happen, to them as a result. And so I have 2 quotes here about the notion of pockets of expertise and sort of assumptions and mental models and forces.
We had other ones that had to do with bad deployment, where the script to deploy that we thought we had didn't work the way exactly we thought it did, and caused this sort of cascading failure or near failure. And in this case, I recall people were on a call, specifically Martin and Dean, and then a few other onlookers, and I came and watched. But Liz made a point of remaining back on chat and monitoring the update status situations. And this was a great move because there's also a sort of semi-explicit policy to avoid heroes at the company, one person concentrating all the knowledge. And in the first one where we had the 99% near outage, Liz was there, explained to Martin and Dean the sort of commands to be running about that one. And when the other incident happened, Liz stayed back and let them do their thing, but still keep an eye from afar without coming in and saying, I know how to fix this one, I'm going to fix it for you. For me, that was the sort of transfer of knowledge that happened over the course of multiple incidents.
And Fred is using the term incident here, but he's talking about near misses, near categories of incidents they had that were still near misses. They didn't quite make it out into the public domain, if you will. And so this has a couple things. One, realizing where they have pockets of knowledge, and then this really fantastic cultural or what have you decision to avoid staying in those pockets, right? And to help transfer that knowledge into the other human's head. So you could say it's not having a hero culture, but also it's like just not letting that knowledge stay within one brain when it needs to be in other brains because Liz can't be there for all the incidents, and you never know. Okay, and then this one, I have not gotten Ray on the podcast, so I don't have a really fancy audiogram of Ray, so I'll just read this one out for you. But I love this description. This was also a near miss. This was something that didn't roll out into the world for them, and it says they realized that this was a failure mode that didn't line up with our mental model of how the job system breaks down. It's very similar to what we were hearing from Lawrence Jones from Incident.io earlier. And this institutional memory is a cultural and historical force shaping the way we view problems and their situations, which I love. And I just rarely hear language like that in an incident report. And they really went much further beyond the technology to understand where cognitive processes played a part in how this played out. Okay, we're rolling into the very end here. So I want the final place that I want to leave you, the depth, the best, the deepest, but not darkest of spending this kind of effort in looking at our incidents is that we're building community by doing this. And this is hard work. Just to reiterate that. Hard cognitive work, as Laura alluded to, or not even alluded to, just very clearly laid out in her talk yesterday. But we're building a community of practice around this kind of work and the value that it brings. We're shining a light on the importance of this, and along the way, we're supporting, educating, caring for each other, which is something that is dearly needed in this kind of work and often not regarded as necessary because we're not nurses or doctors or pilots, but we're doing the same kind of work, and it leaves us in the same state to a certain degree, emotionally, cognitively, intellectually. So just a few thoughts to leave you with on that.
It's really helpful for day-to-day practices of engineers, people who are just trying to do work to understand how we can solve these problems and learn from different areas of how to make this work easier for ourselves. I know that for me personally, it felt like I was an island trying to say, hey, we could be doing this differently. This doesn't have to be so hard. And primarily making it feel like you're not alone. There are other people who are trying to make the same kind of progress, and we can share, pool our resources and help each other out.
Coming out of that, the incident, the first initiative I took on was, hey, we're starting to see a lot of coordination needed among a bunch of teams. And this can't be the same 3 or 4 people. We need to train more people to find these connections and to make them. And so we now have an incident commander rotation comprised of individuals that we would like to expand to the broader org, which is the idea that anyone can become an incident commander. The biggest value I see is safety. Help incident responders feel safe, especially as we are, as an org, scaling very rapidly. So we've been running this program for a few months now and starting to collect some data on how useful it is, how much safer do people feel. I think if we had the program in place for our Wall Street bets, I'm not sure that things would have necessarily been resolved more quickly, but I do think psychologically folks would have felt more comfortable and cared for in a very stressful time.
I love that quote from Courtney. So the last thing I want to say, this is the Void, this is the project I'm working on. It's a big old database, but I would like for folks to also see it as a refuge and a place where I will care for your stories, curate your stories, bring them together, find how they relate to each other, and hopefully educate, illuminate, share, and care for each other through those stories. So you can find me on the Twitters, and that's my email, and because nerds, here's the references slide, and please continue to join me in the depths